Hi everyone, welcome to Skilled Inspirational Academy. I hope everybody had a very good weekend. And this are all the topics today we are going to discuss. This is free CCNA day 9 class. So the list of topics, or we'll discuss about what is the difference between TCP and UDP. And we'll a guy he had some problem with the IP phone lab. So I built a lab and I'll show it for you. It would be helpful for everyone. So we'll go with the IP phone lab and we see how the communication happens between data and voice network and how we can split in the port. And followed by that, we have a ARP lab and theory. And then we discussed about the DHCP and the packets that's been exchanged between client and server. And in addition, we got Dhcp Relay. That's a relay agent. So we'll discuss in detail about that. So let me get started with TCP and UDP. What is the difference between a TCP and UDP? Let me open up my whiteboard. Okay. So let me take this example. TCP transmission control protocol. And UDP stands for user datagram protocol. We all would have heard about this. This is only two transport protocol that's being used. So your application may be based on, TCP or UDP. Only two possibilities. But before that, always it's better, but now we all know, maybe you might or might not aware of this, the whole network terminology and every device, right? Every manufacturer has to stick to the same rule. They have to build their system to be compatible with TCP IP model. So that's the the next generation of OSI in the back 80s. It's been more than 30 years back, the OSI model that developed with. But for networking terminologies, if you see, it's always better to start with OSI. So when we discuss about TCP, we got only 4 layers. The 8 layers has been squeezed up into 4 layers. But still people, when we try to explain and for better understanding to get started, it's always, go with 8 layers, the OSI reference model. That's the best way to understand how the packet flow happens between host to host communication and how this packet is encrypted and encapsulation on the whole process. It's always, worth to imagine with OSI reference model, even though if the whole system, if you see your NIC card, you see the TCP IP stack, but still the OSI reference model is a good way to start with to have a better classification and for better understanding. So let me first start with OSI reference model. So what are the layers in the OSI reference model? So they say, I always remember, there are multiple ways to remember the OSI reference model. The OSI stands for Open System Interconnect. So the layers we got is, there is a different way to remember. You can remember in your own way. So I get used to it. So I'll always write the first alphabet of the 7 layers, A, P, S, T, and D, P. There are many, way of remembering things. You can make your choice and you can remember. And the first layer would say is application layer. Then presentation layer. And then comes your session layer. then transport layer, then followed by network layer, and then data link layer, then physical layer. So always you'd start with, the very first layer, your application, your web browser. So imagine that you got your PC and you opened up your web browser and there is a field to type in your URL, right? So we always get used to this. We'll give HTTP, then followed by google.com. This has been changed to HTTPS now. What S stands for? Security. All your HTTP connection, right? This is your source, your web browser, to the destination, followed by your Google server on the other end. This is your Google server, the communication between your PC and the Google server, unencrypted, plain text. If somebody sniffs this packet, even with their Wireshark, if you try to sniff the packet, this is the first message that in the HTTP it sends a GET request. Hey, get something from google.com, whatever you search, it gets something from your google.com. But this is a plain text and exposed. Anybody can see this. If they do a man-in-the-middle attack, and if you have your PC and if you follow this, TCP stream, you can see all your packet that's exposed to everyone. If somebody is doing a man-in-the-middle attack, they can see all your information. If say, for example, if you're accessing your banking server with HTTP, these days there is no banking servers without HTTPS. With additional layer, that's security. So with HTTP, your texts are plain text, and that can be captured and they can manipulate, and you're exposed, and they can hack your account, and they may take your money from your account. But that's when the HTTPS that came in the middle, and they added one more additional layer, that is S stands for security. This is a primary layer. It makes use of TLS, transport layer security. You would not see this, but if you capture the packet, the TCP packets, you would see this TLS. This TLS handshake happens with encryption, because you cannot make a connection with your server without certificate. That's something like you have your certificate that's valid, that's to prove yourself that you are a legitimate user, right? And your request is a legitimate request. So in the same way, the server would have one more certificate to validate your certificate. And if both the certificate exchange happens successfully, only then you get a connection to your banking server. This is a very high level overview of TLS. We'll discuss in detail when we come to transport layer, because this TLS completely, it works together with transport layer. So the protocols that's running in the application layer, that's example, you have multiple protocols. When you talk about HTTP, DNS, your DHCP, all these protocols that's sitting inside the application layer. So now you are in the web browser and you type HTTP followed by the destination address, right? So what happens here? So in every layer, there is a process called encapsulation. Because this presentation layer, this is not interested to see the traffic, what application layer is sending, because that's not the role of presentation layer. The role of the presentation layer, it's to make the web browser to human readable format, right? So what generally does, so most of your documents, when you open your web browser, that's your HTML, right? They've done with this language, they have built the web browser that's actually converting this back to human readable format. So the presentation layer is actually, that's making the web browser into human readable format from the HTML language, right, to human readable language, to make it simple. So that is the use of presentation layer. So what happens here? So here, say for example, this is a data, this is, you are using a web browser and you are using a HTTP request, right? So we call this as a header. So the HTTP header is added here, right? And this is sending your information back to your presentation layer. So the presentation layer, what happens, whatever the, language that's been encoded or there's been written, the extra layer that added, that's presentation layer header. And together it would be sent to the session layer. So how do it looks? So it just look at as a data. So inside this data, you got two headers, one from your application layer and one for your presentation layer. So what is this session layer? Okay, now your connection has been successfully done with Google server. So how long you're going to use this Google server? Maybe 5 minutes, 10 minutes. So all this session information will be, managed by the session layer. You're opening a Google web browser, Google server, and you're closing it maybe in 5 minutes. So this 5 minutes, the session has to be maintained between your source and the Google server. So all this session will be maintained and managed by this session layer. So for example, you got your Flipkart account open in your web browser, and you got your, whatever shopping, maybe Myntra. These two sessions, how your web browser can differentiate these two connections. So based on this, the session layer maintains individual sessions between the Flipkart and Myntra. That's the use of session layer. This session layer, that's the responsibility of the session layer is to manage and monitor the session between Flipkart and Myntra. Whatever sessions you open, the individual sessions will be managed and maintained by the session layer. So now, as I told you, inside this data, additional header will be added, that's session. One key thing. So when this whole process happens in every layer, that's called encapsulation. Then followed by, the transport layer. So here comes, there are only two protocol that runs inside the transport layer. One is TCP and another one is the UDP. This is reliable. This is non-reliable. Why? Because see, if your TCP connection happens with three-way handshake, let me delete this. Your TCP happens with three-way handshake. The first packet from your client, that sync to the server, and it should send back a snat. That's synchronization and acknowledgement. Then for the synchronization and acknowledgement, it sends a ACK. So what happens when only if this three-way handshake is successful, your data will be, transferred across your source and destination. And one more key thing, this TCP connection is a host-to-host communication. This is sender and this is the receiver. This is host-to-host communication, TCP connection. As we discussed, your application layer, your presentation layer, your session layer, your transport, your network, data link layer, and physical layer. In every layer, the header will be added with the data. So this is data and followed by my application layer header and my presentation layer header. The same way it happens throughout the process. So when it comes to data link layer, I got my data. So inside this data, I got the header information for my application layer, presentation layer, session layer, and transport layer. So this process is from top to bottom, and this is encapsulation. So from here, this is all binaries, right? Zeros and ones. My electrical signals, nothing inside. So all this information are encapsulated and send it back to the receiver. Same layer, right? Application, presentation, session layer, transport layer, network layer, data link layer, and then physical layer. So everything is encapsulated until here and send it across to the receiver. So this is what bottom to top approach. So what happens here? Decapsulation. As I told you, this transport layer communication happens host to host communication. This is very important. Why? If I'm sending a SYN packet, I should get a SYNAC packet back from the receiver. So that is between the host to host communication. So here is your router works, network layer. Why? Inside the network layer, you got IP packet and you got your source IP address and your destination IP address. That is called as IP packet. So inside your data link layer, you got your, what is the protocol? It's called Ethernet. And what is inside that? That's MAC address. There is a two form, okay? One is a hardware form and a software form. They say it's called logical link control, LLC layer. Inside the LLC layer, you got your IP, your ether type header. Why this is needed? So based on that, this information will be forwarded back to the network layer. The LLC does that. So in the sender, it's encapsulation, and in the receiver, it is a decapsulation. So what happens here in the decapsulation part? So the packet comes here, the data. So inside the data, what I got many header information, but inside it is interested to strip only the data link header, right? Your Ethernet MAC address. So only it strips out the Ethernet MAC address. Okay, it will get to know, okay, this is the MAC address of 10.0.0.1. Okay, I got the MAC address. My job is done, and I'm going to send this packet back to the network layer. So now, what are all the information I got here? So now I got the header value for network layer header, followed by transport layer header, session layer header, and my presentation layer header, followed by my application layer header. So this is HTTP request, right? So in the network layer, whatever I got my source and destination IP. The information will be stripped out and send it back to transport layer. So what is the communication happening between source and destination? It's an HTTP request, right? From your web browser, you have opened your HTTP connection. So how, see, transport is very simple. So if you want to if you want to courier something to your friend, so how this transport would be? Through airways, through shipping, waterways, then roadways and railways. This is called as transport. In the same way, the transport, how your transport is going to happen here, through two protocols. One is TCP and UDP. As we discussed, TCP is reliable because it should maintain a three-way handshake. Once the three-way handshake is successful between the source and destination, only then your data will be forwarded back from source to destination. If your TCP handshake fails, your data will not be sent. So something like if you want to send your packet through your roadways, right? Example, if you want to send your packet through roadways, what happens if you are making a query, you get an acknowledgement, right? Hey, this is your friend and you're going to send this courier back to him. This is the address. And this is maybe if you're tracking your order, how this information is coming back. Okay, it is in the middle of Delhi, Mumbai, and my destination is Jammu and Kashmir. It reaches Jammu and Kashmir, right? So you get all this information as an acknowledgement. Okay, the package, the delivery is been, that's progressing to Delhi and it's on the way to Jammu and Kashmir. You get this acknowledgement back. In the same way, in the transport, if you're sending a data, say for example, you're downloading a song with 1 MB, this information will not be sent it as a whole. It will be a chunk of data. Right, let me clear this. It's a chunk of data, right? In your TCP, it's a chunk of data. So this is very important. 4 parameters. In your network layer, it's called as packets. This is your CCNA question. The data link layer, they call it as frames. In the TCP transport layer, segments. Data link layer, frames, packets, and segments. You should be aware of. And this is L2, and this is L3. This is L4. So what the TCP exactly has inside, so it got about your port details. Say you are doing your DHCP request from your source, right? What is the port number used? 67 and 68 in the destination. So all this port information will be mapped to TCP. So that's why people, they ask a question, so what is the well-known ports? What is random ports? If a PC is sending a packet, right? If it is making a, web request, you're doing a web browsing with HTTP. So on the other end, the port 80 should be open, right? So your source IP is 10.0.0.1, and that comes with the port number 006. Example, this is random port generated by the operating system. You have no control with this random port generation. But the destination port is always static, that's 80, because that is well-defined ports. Do you see any PCs that sends with you can send a packet with, you can send the HTTP request with source port 80? No, that is not possible, because this is well-known ports that's assigned for a specific communication. So here you're doing HTTP communication, and the port 80 is used by default for all your web servers. So how this packet is distinguished based on the ports. So all this port information will be maintained by the TCP ports. So if you want to, do a file transfer protocol, FTP, if you want to do a file transfer inside your web browser, you type FTP : your destination, maybe example 10.0.0.1, 20 and 21 is the port number used. This is well-known ports. All this ports information will be managed by this TCP layer, transport layer. So the transport layer has two protocols that is utilized. One is your TCP and UDP. You try to capture a packet when you try to open your youtube.com. It uses both your TCP and UDP ports. Your DNS uses both your TCP and UDP. You should be aware about all this, the fundamentals. Only then you can do a troubleshooting when somebody is saying, hey, my web browser is not working. Is it something is blocking on the client end or destination end? So you'll do a capture and you will see what is the port information I got, and is it the port is communicating back, and all those details you can see. Right, if you go back to the network layer, you got your IP packet. And so inside your IP packet, you got your source IP, your destination IP. So based on this, your packets will be forwarded back. Always remember one thing. If you're making a communication between your source PC and your destination PC, if you actually see the packet capture, the source IP and destination IP will never change. Only your MAC address changes. We have a concept of ORP. There we can see in depth about the ORP flow and how this ORP exchange happens, and what is the characteristics of ORP, how it works in detail with packet flow about ORP. So this is so far with the network layer, and final layer we got your data link layer. So what is inside data link layer? You got your MAC address. For your LAN protocol, your Ethernet protocol, you got your, let me delete this. You got your switch and your PC, and the communication happens between the PCs, the switch standpoint, switch perspective. It's based on MAC address. What is the protocol used for this? Ethernet protocol. So in the same way, if your communication is happening through router and you got one more switch on the other end, the communication happens here based on WAN protocol on layer 2. They call it as HDLC and PPP. So this is not used these days, very less, maybe very legacy links they keep using running this, but most used protocol in the data link layer is Ethernet. That's MAC address. So all the LLC does inside this data link layer, you got one more protocol called LLC, logical link control. So what it has, it got the ether type. What is ether type? That's a number given to find out your IP schema. So based on that, it forwards this packet back to your network layer. And a quick recap, since we discussed multiple concepts together, I'll make it as simple. Source and destination, and you got to know what is the packets that's been embedded or encapsulated in every layer, right? So from the sender, it's encapsulation. And in every layer, the inside the header information, the upper layer information will be encapsulated. That is called header. So when it comes to data link layer, I got a header from application layer, presentation layer, session layer, transport layer, and network layer. and it adds this MAC address information, the data link layer, and send it across to the receiver. And here happens a decapsulation. This is bottom to top approach. So in every layer, the decapsulation happens and reaches your HTTP. So I would say this application layer and your transport layer, right? That's married together. It shares this information about the port number, right? And the protocol used in the application layer. Say, for example, this is HTTP and this is my port. How do I find that? And the communication between transport layer and from the source and the receiver is the host to host communication. Now let me open the, now let me open my whiteboard. I'll show you this. You'll understand better. All together into diagrammatical representation. Can you see this? The whole thing. This is process to process communication. So in your application layer, your communication happens, right? Application layer, your communication starts from your PC. As we discussed, we open a web browser, and the OSI reference model is being just for the visual to understand better. We always learn with OSI reference model, but when it comes to the real world now, it changed as a TCP/IP model. So this is host to host communication. I'll show you the TCP/IP model. So this is a host to host communication. We discussed about the SYN, SYNAC, and ACK. This is from source to destination, SYN. And this is a receiver, it will send back a SYNAC, and this sends an acknowledgement. And this 1 MB data that's segmented, right? And every chunk of data that has the individual sequence number, connection ID. This is all needed, to differentiate. Okay, this is the sequence number 1. And in the 1 MB, I got, only 500 KB has been sent. Other chunk of data, you got a sequence number 2. Connection ID is 2003. That's randomly generated. Sequence number 2. And my other 500 KB. So it's splitted into 2 parts, and it would be sent it back to the destination. Why this is needed? If something happens in the middle, see, if the receiver haven't received this second chunk of data, it's never going to send the SYN/ACK from the receiver, right? So what it would think, the sender, okay, he didn't receive it, so I have to send this back again. I have to send this back again until I get an acknowledgement. And it is a time consumption process, but it's a reliable transfer. Because I'm pretty confident that, okay, my packet is being sent because I got an acknowledgement for the same. Whereas in the UDP, that's connectionless. What is the best example of UDP? If you're watching your YouTube videos, if something happens in the middle, you feel any difference? But if you want to install an application, you're downloading an application with 50 MB. If you lose 1 MB of data, you get only 49 MB data. Can you install this application? No. Why? Because all this information has to be, encapsulated, or I need all the information inside that application. Only then the application is functional. But whereas in the UDP connection, if I'm watching a YouTube video and I'm dropping a connection in the middle, and suddenly, what happens? Boom, and it comes to 5 minutes. If it is a 5 minutes video, I'm losing a connection for 2 minutes, and suddenly it jumps back to the 4 minutes 36 seconds, and the video starts streaming, right? That's because, hey, whatever you listen, I don't listen. I don't look for the acknowledgement, nothing. I'll be keep on sending the data from the sender to receiver, keep on sending the data. If it is drops, I don't care, I keep sending data. But for the application and for the softwares, so all these kind of application, they rely on, you know, TCP. And the video streaming, they are, you know, least bothered about if there is a 5 or 10 packets that's not actually, you know, reaching the destination. I don't bother. Still the conversation continues even if I'm losing. If you're in a video streaming, if you cannot hear on from the receiver end, you'll ask them to repeat, and anyhow you'd be getting back your information. But in this TCP, if I didn't get a chunk of data in the middle, I cannot install the application. That's the key difference between the TCP and UDP. Can I say this in the inside the physical layer, you do all this. This is a 10 base T, and you got your fast Ethernet port, and that is 10 Mbps, your 10 Mbps cable that's connected to your NIC card. So here, see, this is all comes into the physical layer. The Ethernet is all your MAC, and you got your additional layer LLC. So here you got your source and destination IP. So the transfer, how I want to transfer, I want to do a video stream, then it's an UDP. Okay, I'm going to send an application. I'm downloading an application, then it is an TCP. And what is the port number used? 80. And what is the protocol used in the application layer? HTTP. So two are married together and this exchange this information back, and I get to know, okay, this is HTTP request. So the presentation layer actually does your encryption. Your data should be encrypted from source to destination. Nobody should see that. And along with that, the HTML will be changed back to human readable format. So this is pretty good diagram to represent about, you know, the data flow in the TCP IP model. Let me delete this. The very best, diagram, I would say to follow up. Because from this application, you see there are different mode of communication. Here I got an Ethernet connection back, and here I got a fiber and satellite, right? Your communication is not happening through, you know, this is your router and your PC is here. It's wired connection. You got your ISP cloud. It inside the ISP, you got multiple technologies for your WAN, right? It's not only your wired connection. There might be a VSAT connection. There you got one tower here, and you got one more tower here, a point-to-point connection. So all your information will be sent across the radio waves, not through wired connection. So that's the representation of the fiber, satellite, and other technology that's used for WAN connection. So here your encapsulation happens, and here your decapsulation happens. And this is a host-to-host communication, and this is process communication because it is an HTTP based or TFTP based. It's a, you know, end-to-end communication. That's the reason they call it as a process-to-process communication. So this is a deep explanation about the TCP IP. And I'll show you a couple of diagrams to understand better. Now, the key difference between the TCP and OSA model. So always you have to learn with, you know, I would say you should always learn with OSI reference model. Should always learn with OSI reference model. So what happened here, this 3 layers has been squeezed into 1 layer. So inside your application, your presentation session layer job will be done inside the application layer itself. 3 layer, the job of the 3 layer has been done by the 1 single layer, that's your application layer. But the mechanism is same. Your transport layer is same transport layer, host to host communication. So what happened here, they call this as an internet layer. You got your network layer, your IP information. and your data link and your physical layer will be changed into one single layer. That's called network interface layer. So now in the current deployment, everybody is running with TCP IP model. So what it means, see, hey, this is an open standard irrespective of your Linux, your Mac, whatever operating system, your Kali Linux, everybody should agree to this protocol. They have to develop their operating system based on TCP IP. Only then it is interoperable between the operating system. What happens if I make a communication with my Windows PC and they are not, they are not developing their operating system based on TCP IP model? Your connection will be dropped. So both my communication should happen with a one familiar protocol, that is TCP IP. That's when this protocol came in. Say I'm sending a back information back to you, and you should understand. If you want to understand, you should know what I am sending. So everybody should be rely on, and we both should agree to use same protocol. That's called TCP IP here. So inside your TCP IP stack, you assign your IP address if you open up your NIC card, and so you can see that. So this is the fundamental understanding about the TCP IP model. And as we discussed in depth about the encapsulation, decapsulation, and what is the functionality of transport layer and what is the functionality of internet layer, we discussed as it's a network layer. Inside the network layer, you got your IP packet. Try to visualize the whole thing, go through one more time, and try to get familiar with all these terminologies. This is very important. This is a basic foundation to understand about the network communication happens between the source and destination. Okay, let me delete this. So let me start with the Dhcp relay, and then we'll do IP phone lab and ORP lab and theory. So we all discussed about the Dhcp in detail. And I'm so excited, and I want everybody to be interactive in this session. We discussed about Dhcp in the last class. So here is a question for everyone. The Dhcp Discover is a unicast or broadcast? You can post your answers in the chat. You can write to me on the chat. You're most welcome. Dhcp Discover is a unicast or broadcast. Dhcp Offer is a unicast or broadcast. Dhcp Request, unicast or broadcast. And Dhcp Acknowledgement, unicast or broadcast. Let me see your answers. Okay. Somebody wants to repeat? Okay. Your Dhcp Discover is a unicast or broadcast? I can consider this a request. Okay, this is what I expect. If you send your answers like this, that would be helpful. So Dhcp request is a unicast. So who is sending back the request? Discover, offer, request, and acknowledgement. Let me go through this quickly. Discover from client. Offer is from the server. request is from the client. I'm okay. Discover, offer, request, and acknowledgement, right? Discover is a broadcast. That's correct, because I don't know my IP address, so I said the discover. That's right. So somebody said, what is that? My request is a unicast. Request is actually a broadcast, right? It should be sent from the client. Let me open the packet capture. Let's go through this. See, this is a discover. This is a broadcast, right? This is a layer 3 broadcast. Why this IP address is used? Your discover is a broadcast. That's right. And your request that's coming in from, that's again, see, the request is coming from the client. That's not a unicast. That's broadcast. See, make it simple. From all your client request, there's a broadcast. What are all the two broadcasts happening? The discover and request. Both are from client. You can see this packet capture. You can see this. This is C broadcast, layer 3 broadcast. And what else? That says discover is a broadcast. Okay, good, cool. I think many students give the correct answers. Awesome. I mean, okay, you guys are getting it. Really happy. So see, this is a layer 2 broadcast here. If you take your discover, you have to be more specific about your L2 and L3. This is a broadcast, layer 2 broadcast, all Fs in addition. And what is the port used here? What is the protocol used? UDP. And what is the client port number? 68, right? Can you see this? This is from the client end. And this is for the server. The server will respond back on port 67. What is the protocol used? UDP. So this DHCP works on application layer. And this UDP works on transport layer. Right, let's drill down the dynamic host packets. So you got your, as we discussed, you got your usable IP address, your client IP address requested for. See, still here, your information, it's not agreed with that. So all zeros. You got your domain name, server details, and all that. So inside the DHCP request, you have to find one more thing inside the discover. So the offer from your offer packet, you get your DNS information. You can say this is a bonus information you can give when somebody asks you a question. What is inside a DHCP discover and what is inside the DHCP offer? You can say it's not only sending the DHCP discover. When the DHCP server is responding back with the offer message, it gives the IP details along with my DNS information. So that's the reason I get to know my DNS server and my DNS resolution is happening. If I'm typing google.com, what is the IP address that's binded to google.com? I get this detail because this DNS server details I got from the offer packet. Right? If you go back to your offer packet, if you strip out the information, can you see this? Option 6, inside the option 6, I see the DNS server. Here it's my local broadband DNS, public DNS. This helps for my DNS. So we have one more class in detailed about the DNS. Yeah, I'll tell you what is a root server and how this DNS query happens from the client perspective and what is the process goes on until it gets to the DNS server and your FQDN resolution happens, how it happens, and where the information are stored inside. What is DNS cache? We'll discuss in detail about that in the same way how we discussed about every concept. We'll go up to the packet level to strip out the information back. Congratulations, guys. You guys have given, very good answers. And this would be, helpful for you to, upskill yourself. You can, understand better about the DHCP when you do a packet capture and see this. So this is a, simple packet capture I did from here. It sends a discover, right? This is an offer sent from the server. You should understand this flow. That's important. This is from, say, discover from client to server, and the offer is from server to client, right? And the request comes from the client to server, and the acknowledgement comes from the server to your client. But I think we talk more about the DHCP. I hope everybody would know about DHCP in detail now. So we'll discuss about the relay agent and why we need a relay agent. So this is DHCP. We understood discover, offer, request, acknowledgement. This packet exchange happens between the client and server, and I got my IP address. That's fine. But why I need a relay agent? What is that relay agent? What is the job of it? The network. Let me show you that. For that, let me open up my whiteboard. Delete this. Let me take this. This is your PC. This is your switch. PC is connected to it. So you got 3 office, imagine, example. So you got a router. Definitely I need a router to, connect multiple networks. So this is called WAN. A wide area network connecting different LANs. And I got PCs connected to it. This is my switch. This is 10 network. This is my 20 network. This is my 30 network. Sorry for that. I think I made one more. 1, 2, 3. Let me delete this. So this is 20.0.0.1. Write this 10.0.0.1 example, and this is 30.0.0.1. So I cannot deploy a DHCP server for every subnet. That's a painful process, right? So I have to have my DHCP server for every network. You have to spin up. If your offices keep on growing, you got about 30 plus branch offices. Is it a best practice to deploy your DHCP server in every location? So I need to run 30 DHCP servers. I have to have a 30 physical or VM based DHCP. I have to deploy, and I have to manage all this DHCP server. That's a painful process. But what if there is a possibility to have one server that serves as a DHCP server for all the location, all the 30 location? If that is possible, that's very easy for me to manage from the management perspective, admin perspective. You can troubleshoot in one single box. I log in this device, boom, and I do a troubleshooting, and I can manage all the networks here. If there is one more new network that's coming in, new office, I'll add only the network information related to it in one single server. I can manage from here. So how do this, the DHCP packet will be forwarded to this DHCP server? That's a question, right? If I got my DHCP server inside my local LAN, the request will be forwarded. I send the discover. Since my DHCP server is in the same network, the broadcast for this broadcast, it should answer back. It will definitely answer for my broadcast because it is in the same network. If my broadcast, if I'm doing a broadcast and my DHCP server is on the 30 network, my broadcast will be dropped here because this is not in my network, right? So I need a device, or maybe how to say, I need something in the middle who can actually forward my broadcast to a DHCP server. So that's the use of DHCP relay. So what happens here? Imagine this is your switch. Let me make it as a very simple topology. So you got your 10 plus VLANs here. You got your 10 VLANs. Got your 10 PCs connected. Every PC is in a different network, different VLAN, different broadcast. So my broadcast, the DHCP server is actually on a different switch. So on VLAN 30 example, but I got the VLANs only 10, 20, 40, 60, 90. But my broadcast domain 30 is not in the same switch. So what it does, inside your router and your L3 device, there is a capability to run your DHCP relay agent. What it does, for your DHCP broadcast, it would say, hey, I don't have the DHCP information, what you're looking for. The DHCP server is not connected to my local network. But anyhow, I'll help you. I'll forward this DHCP broadcast as a unicast with my gateway. See, this is VLAN 10 and the IP assigned is 10.0.0.2. But the DHCP server is on VLAN 30. But inside the DHCP server, what you got? You got your network information. What is the network information? You got 10 network, right? Obviously, you should have your 10 network running inside. So you give your source IP, sorry, your starting IP address, usable IP address till 10.0.0.254, last usable IP. Example, this is /24. So from here, I got my subnet mask. Is 255.255.255.0. So what are the three parameters that would be forwarded back to this discover? The IP address, the usable IP address, gateway information, and the subnet mask. I'm only interested in these three parameters. If I got this, yeah, this client starts communicating back. It got an IP address. It shows us identity. Okay, I'm also inside this network. I got this IP details, my gateway information and subnet. I'm ready to go. I can send this packet to any destination because I have an identity and I know how to reach. So I got this network details inside the DHCP server that's sitting inside VLAN 10. So what is the IP address assigned to this DHCP server? Since this is on 30 VLAN 30.0.0.2 example. So what happens? This DHCP broadcast that comes to this router, this is the gateway configured for 10 network, and the command is IP helper address. Hey, help me. I don't know where is my DHCP server, but I know the IP address of the DHCP server, that is 30.0.0.2. So this broadcast, will be changed, not changed. Once I receive this broadcast, it come to know, okay, 10 network wants an IP, this network, I got this broadcast from my network. And since this is my network, I know about my IP details. So I need a request for 10.0.0 network, right? And I have hard coded manually this is your DHCP server 30.0.0.2. So what is the information it will put inside the packet, DHCP packet? Now the DHCP Discover packet will be dropped in the gateway, and the unicast packet will be sent with the source IP 10.0.0.1 because that's my gateway. And I know the IP helper detail 30.0.0.2 and this unicast information. Since I got the IP helper configured unicast, I know where it's in my DHCP server now. This information will be sent it back to this server. So what is inside this server? It will check, okay, what is inside my database? Okay, 10 network. For 10 network, this is the starting IP address and this is the last usable IP address. Here you go. Get it your IP address 10.0.0.2. Send this back to unicast because I know where it come from, right? This is very important. See, the request come from the 10 network. So this information is send it back again to the same 10 network because from the unicast packet, it come to know about this gateway 10.0.0.1. So what happens now? This 30.0.0.1 will send this usable IP address 10.0.0.2 to 10.0.0.1, right? So now this 30.0.0.1, my DHCP, actual DHCP server will give a valid IP address 10.0.0.2 to 10.0.0.1 because my unicast came from this all the way back to the same place 10.0.0.1. So once it reaches 10.0.0.1, here my switch, and this is my PC, this is VLAN 10, so it gets an IP address 10.0.0.2 because this DHCP server gave this, because inside this database I got my 10 network. So in the same way, inside my switch, if I got VLAN 20, the same thing, it comes back to my router and the gateway is VLAN 20, and it puts this information back and send this back to my DHCP server. So inside my DHCP server, I got the IP details for 20 network. So the same way, like I got a unicast packet from the 20 network 20.0.0.1, and this is your usable IP address from the DHCP server 30.0.0.1, and this information will be sent back to 20.0.0.1. And what is the usable IP address 20.0.0.2, and hey, client, have this IP address, enjoy and start connecting to your network. So this is the role of DHCP agent. If see in the even in the typical network design, if you see, we got our data center. Even now, maybe it's called as a hybrid technology. You got your some of your application that's hosted on the cloud. They call it as on-prem. We discussed about that. So I got my DHCP server here. I cannot keep in the cloud. Example, I'm saying you can deploy that. But for this example, you got your many branch offices. You got your routers and you got your switches connected to it. Now, this is all your routers. Branch office 1, branch office 2, branch office 3. So you are all connected to one common cloud. So your WAN connection is connected back to your ISP, and you from the cloud connection, you got your ISP for this data center, and you got your internet link, and you got a device here. So inside this, you got a switch and you got your DHCP server. As we explained, from this VLAN, this information will be, forwarded back to this DHCP server and get this IP address back and assigned to all the PCs for all the DHCP broadcast, that again would forward as a unicast from by your router and gets this IP address back and assigned to your PCs. See, concepts is very important. There's one single command. Why I'm giving such a long explanation, that's because I want you guys to understand the same way how you are understanding all your concept. This is the use of DHCP relay agent. Since we are about to end the session, it's already 9. I don't want you guys to dump so much of information for one day. So this is the concept of a DHCP relay agent. So we'll do a lab tomorrow, the same thing. I hope today we got a very good very great discussion about the TCP IP and DHCP relay agent. And today class was very intuitive. You guys have posted answers. So the same way moving forward, you keep post your answers and I'll ask simple questions. It makes us, too much, the class will be too much intuitive and we can interact. So you will understand better. Somebody's asking a question and you start thinking and you answer about that. You get more familiar with your concepts. So we discussed about DHCP relay and TCP IP, and a quick recap. We discussed about how this encapsulation happens, what is decapsulation, what is host-to-host communication, and what is the header information that's inside every single layer, and how this is sent it across to source and destination. And what is DHCP relay? We discussed about DHCP and what is unicast broadcast. Yeah, and your unique DHCP relay address, since you hard coded the IP address, it's always be an unicast packet. So inside this, the DHCP packet, if you strip out this particular information, this header, you will get the GIDR address. That's called gateway address. Because based on this address, your reply for your unicast request, you will get a unicast reply. Because how do this server know that where it comes from? Through this gateway address that's configured on your router. Okay, this broadcast has come from 10.0.0 network. Okay, I'm going to give this back to 10 network. Okay, this is an unicast for 10 network. I'll give a unicast reply for 10 network. Yeah, that's all about DHCP and TCP. And I hope everybody enjoyed today. I'm happy to meet you all tomorrow. Have a great day then. Bye.